Hi, I'm Will Rostron, an Applications Engineer with Sealevel Systems. System designers often use our I/O devices with high-level languages such as C++, C#, and Visual Basic, but you don't always want to write your own program. Sealevel offers many digital and analog I/O adapters that are compatible with the industry-standard Modbus protocol. One of my favorite third-party software choices is DAQfactory, made by Aziotech. DAQfactory provides an easy-to-use graphical user interface for Modbus I/O devices. These devices are commonly used for many applications such as process control, data acquisition, or remote monitoring. You can download a trial version of DAQfactory or purchase a license from the Aziotech website. Here I've put together a demo showing DAQfactory and our CIO 470M module controlling a motor. This CIO 470 module connects to the computer via RS-485 and uses the Modbus RTU protocol. I added a serial port to the host computer using a Sealevel 2107 USB to RS-485 converter. I used a DB9 to RJ45 modular adapter with an RS-485 interconnect cable and plugged the RJ45 cable into one of the RS-485 connectors on the 470 module. The 470 module is a multifunction I/O adapter that supplies 8 isolated digital inputs, 8 open collector digital outputs, 2 analog outputs, and 16 analog inputs. I used a 24-volt DC supply to power the CIO module and a motor with integrated controller from Anaheim Automation. I used an analog output to control the motor's speed and an analog input to track the control voltage. I used open collector outputs to control the brake and change the direction of the motor. The motor is powered by 24 volts DC. P ground is a common ground between the motor, the power supply, and the 470's I/O. Run stop is used for the electronic brake, which stops the motor instantly. PG out could be used to calculate the speed of the motor, but it is not used here. V speed is the motor's speed control. It has a 0 to 5 volt range. If you just zero the speed control voltage, the motor will coast to a stop. Direction reverses the shaft rotation. Plus 5 volts out could be used to control the speed with a potentiometer, but it isn't used in this demonstration. DAQfactory provides a set of HMI components that can be used to display text, create action buttons, graphs, and other useful functions. The DAQfactory software supports a top-down design and bottom-up implementation scheme. Start by designing the pages based on how they will be used, adding the user interface components. Choose the Sealevel hardware I/O points, which DAQfactory calls channels. Create the hardware connections. Add the channels you selected previously to the DAQfactory document. Set the actions of the user interface components to read and update the channels. For more complex actions, create sequences, which are scripts that run in the background. And finish by debugging and testing. Now that we've covered the DAQfactory basics, I'm going to demonstrate our fully functioning application. This application example works perfectly in a DAQfactory Express installation. More sophisticated controls and capabilities are available in paid versions of DAQfactory. Our application only requires a single page. We group the components by functionality. Most of the components let you directly control the outputs to the motor. The top component controls the motor's speed. The next components let you set and release the motor's brake. The reverse button changes the motor's direction. The graph shows you the time-based history of the motor's voltage, or RPM. The channel table view is a nice overview of the channels. We use one channel per output or input. Notice that we name the channels according to their function, and the channel details include device number, I/O type, and zero-base point number. This gives us the flexibility we need to add more CIO modules and change which I/O point a channel uses. Sequences run as separate processes in the background, so the user interface and data collection does not have to stop while sequences run. The initialize sequence creates variables and sets the initial output conditions. The control loop sequence limits the motor control voltage. It also updates the brake button colors. The change direction sequence changes the motor direction carefully. It's kicked off by clicking the reverse button. As we increase the motor control voltage, the motor speeds up, and it slows down as we reduce the voltage. We can't set the control voltage higher than 5. Setting the motor to 0 slows the motor to a stop. Hitting the brake stops the motor quickly. Clicking the release lets it resume its set speed. Clicking the reverse button starts the sequence that stops the motor before it reverses. Notice how the RPM graph tracks all of the changes that we made. This application demo was focused on controlling a motor. You could easily take these controls and integrate them into a larger DAQfactory application. For detailed information on how this demo was created, visit the Knowledge Base article on the Sealevel website at the link shown on your screen. You can also download a copy of the sample DAQfactory application used in this demo. Sealevel offers a complete line of CIO devices, each compatible with DAQfactory or any other Modbus compatible software. Additionally, our CDAQ family of USB digital I/O adapters and EIO, Ethernet, and PoE digital I/O modules offer the same Modbus compatibility. Find out more on our website at sealevel.com or give us a call at 864-843-4343 to discuss your specific application requirements. Thanks for watching.